topic of our presentation today is integrating analytics, third-party data, and actuarial assumptions. So I'm Mike McPhee-Anderson. I'm a Senior Assistant Actuary at Reinsurance Group of America, and I'll be presenting a portion of the presentation. Kyle, would you like to introduce yourself?
Hi, I'm Kyle Noby, and I am Vice President and Advanced Analytics Actuary, working with Mike in our Global Data Analytics Department.
So when we're talking about third-party data sources, I think it's important to discuss why we use third-party data in addition to the types of data that are available. So reasons to use third-party data include operational and underwriting efficiency. So in the United States, fluidless and triage models have become quite common. So one of the major barriers to purchasing life insurance for many consumers is the invasive underwriting process, which would involve like a blood draw and urine sample and sending an examiner out to someone's house. So rather than performing this invasive and honestly costly procedure, a lot of times third-party data will be integrated so that they can look at, so a carrier can look at, for this individual, is this process likely to add protective value to the underwriting process? And if the answer is no, because they have a high credit score, they don't have a lot of prescriptions, then they'll just sail through that process straight to the offer of insurance. Now, if there's something that comes up in the third-party data, such as a prescription or maybe a credit variable that's of concern, they would go through the traditional underwriting process where they would go through the fluid collection. So that's a great example of operational and underwriting efficiency on the individual life insurance side. But on the group side, we're starting to see some use of third-party data as well. So group underwriting can also be very time-consuming, where if you're trying to insure, say, an employer group with life insurance, you need to look at what's the average salary, what's the industry, what are some geographical factors that would influence this. And you're also competing against multiple carriers. So if you don't win that bid, that's not a great use of your time. So we're also starting to see integration of things like health claims data, credit data, things like that into the group insurance context as well. So other uses of third-party data would be things like in-force and experience analysis. So if you have a pocket of business that is performing much worse than expected, say that's high mortality, high lapses, you can integrate third-party data to see, will this trend continue? Perhaps with mortality, you had a pocket of people with very low credit scores. So that when that pocket of people dies, you would expect that mortality would improve. The remaining lives have much higher credit scores. Therefore, the ongoing experience will be much better. Same thing with lapsation and withdrawal. Perhaps you have lapsation among very low credit scores during an economic shock. And so you're expecting people are maybe tapping those savings insurance products, or maybe just can't afford the premiums any longer. On the other side, if you have lapsation and withdrawal among high credit data, that may be that your most efficient policyholders, the ones who are the best at managing their money, are seeking better deals elsewhere. So with those insights that you gather during your in-force and experience analysis, you can then move on to integrating that into your pricing basis. So when we integrate a third-party data source and use that to charge people high premiums or low premiums, we call that risk segmentation. And third-party data can enable better risk segmentation. So with that said about the use cases of third-party data, let's talk about what types of data is available. So as we've discussed, credit data is quite commonly used, and there have been a number of studies that have shown it is highly correlated with mortality. In addition, there is marketing data. So things like, what is this group of people, or maybe this individual's propensity towards certain types of consumption, like alcohol, or maybe whether or not they're savvy with their money, even brand data, whether or not they're consumers of certain types of brands. That would be found in a marketing data set. Next, you have health claims data. So pharmacy data is used very frequently in individual life underwriting. So looking at does this person take a drug that would be of concern? So something like maybe heart medication or even chemotherapy. Things like that could be found in pharmacy data, and that's commonly used in the United States for individual underwriting. Medical claims are things like perhaps they had a CAT scan or something along those lines, and that type of data can be integrated as well. Finally, we have behavioral data. So things like criminal records, motor vehicle records, those are often captured in risk scores and integrated into that third-party data risk segmentation process. So as we talk about ways to integrate third-party data, it's important to first start with an evaluation. So we present here a framework for understanding third-party data that consists of two components. The first is an analytical evaluation, and the second is an actuarial evaluation. So analytical evaluations are all about quantifying individual relationships. So whether that's between your third-party data and the insurance event or risk of interest, such as mortality, you're seeing if, say, a smoker propensity variable relates to mortality. But it's also very important to think about how does this third-party data correlate to my existing risk factors. So things like underwriting classes, whether or not it was, say, a smoker versus non-smoker was what they checked on the app. So things like that also need to be quantified using correlation. Now that's an analytical evaluation. So the key questions we're trying to answer are, do existing risk factors correlate to third-party data? Again, that's things like, does what the policyholder reported as being a smoker, does that line up with what the third-party data says about them being a smoker? And how strong is the relationship between variables? Is it that 100% of the time that someone says they're a smoker, the third-party data says they're a smoker? Or is it weaker than that, say 50% of the time? And so finally, which other risk factors are related to which third-party variables? So it might be that low face amounts also have high smoker propensity. Those are the types of things that these analytical evaluations will answer. So the key point again with an analytical evaluation is to quantify the correlation between the third-party data and risk factors that you probably already have in your insurance block. And so those are things that you would have collected on either the application or during the underwriting process. So common risk factors that are used today for insurance to set different premiums or maybe just understand from an in-force perspective how the block is performing are things like proxies for wealth. So face amount or benefit amount, typically higher face amounts are on a life insurance policy or sum assured, however you would like to call that, are correlated with wealthier individuals. And so there may be actually lower premiums for more insurance, for higher face amounts. The next is product type. So you have these pure insurance products, so things like term insurance versus life insurance that has integrated savings components into it. So that's universal life insurance in the United States. So typically those are purchased by more affluent consumers. And finally, postal code. So things like high income levels in a postal code could very well indicate that that individual is wealthy. So those are the proxies for wealth that we may have today with our data. Next is the proxies for health. So underwriting class are things like how healthy is this person expected to be and how much should we charge them for life insurance. So you have smoker classes, you have standard, which is typically the lowest in the United States. And then you also have things like preferred and super preferred, where the mortality is expected to be quite a bit better than the standard class. You also have gender. So male and female rates are typically different, and age. Obviously, as you get older, we charge you more for insurance. And so those are all proxies for health. Now, among third-party data, what are the proxies for wealth that might be correlated to our existing risk factors? So things like credit variables, which would include scores, utilization, so how much of this person's total borrowing capacity are they using, or derogatory items such as late payments or defaults on loans. So those are also very good proxies for wealth and commonly found in third-party data sets. Next, with marketing data, you have things like propensity to consume. How much money does this person spend? Types of consumption. Do they spend a lot on alcohol? Do they spend a lot on tobacco? Do they spend a lot on things like housing, things that might be cutting into their finances? And also the savings rate. How much of this person's income are they able to save? Proxies for health. We have medical data. So again, as we talked about, you can get, as part of the underwriting process in the United States, you can get automatic checks of people's prescription histories with their authorization. And you also have diagnoses. So you can look at, does this person have cancer, et cetera. And actually, wealth proxies can also be useful for health too. So credit variables tend to also be correlated with mortality. So how do you compare these existing risk factors that we have to the ones in the third-party data sources? So that's where these things called correlation metrics enter the picture. So down at the bottom of the screen, we can see that we have current risk factors, we have third-party data, and the overlap between the two is going to be correlation. And so we should expect some correlation between our existing information and the new information. There's 3 different measures that you can use. So Pearson is the most commonly used, and that's just the way that when people say correlation, they're probably talking about Pearson correlation. And so that's a measure of linear strength. If a third-party data set has a 10 for a score and our current risk factor has a 10 for a score, and then there's a 20 for the third-party data and a 20 for our current risk factors, that would be a linear correlation. What Spearman and Kendall's tau lets you do is when that is nonlinear. And so maybe our current risk factor is a 1 and the third-party data is a 10. The current risk factor is a 2, the third-party data is 100. So when it isn't linearly increasing, we want to use those other measures. So if the question is, which should I use? Start with Pearson, and if you can, compute a second one and see if the answer is different. So multiple measures are always better. So looking at the smoker propensity distribution, or what we're looking at here are geographical regions and how likely people are within these regions to smoke. So we see on the far left that there's about 750,000 areas with extremely low smoker propensity, meaning the people living there are very unlikely to smoke. And on the far right-hand side, we see there's about 1.5 million with extremely high smoker propensity, meaning people residing in those areas are very, very likely to smoke. But the vast majority of people are somewhere between low and high. So when we're looking at correlations between smoker propensity and population mortality, we should first look at that distribution to see what does the third-party data say for the range of scores that we're going to line up with that mortality. And here we see that although there's about 7 different buckets for scores, that the vast majority of people are towards the center. So this can actually impact our correlation, and we'll see exactly how that happens. So if you look at the smoker propensity distribution as is, the correlation is 0.32. But if we take that distribution and we take the 750,000 areas with extremely low and sample 750,000 from very low, low, average, high, all the way up. So rather than having that bell curve shape, it's flat. And every other area except extremely low is a random sample of 750,000. We see that our correlation actually goes up. So we have 0.32 in the original distribution and 0.40 in our stratified distribution. So that leads us to the conclusion that extreme values are much more informative. So if it was pretty much the same, that would mean that we should use the whole range of values. We should say, all right, if somebody is average, we should say they live in an average smoker propensity area, and that's useful. And if that difference between correlations is extremely high, what that leads us to is saying we will only consider extremely low and extremely high smoker propensity as a useful data point. Everything else is just, we'll merge it into one bucket and call that average. So subtle points are that the distribution of your third-party data will impact your correlation. So be sure that you compute it both on a stratified basis and the original basis and compare the two.
Next up is the actuarial evaluation. So first, I'm going to explain to you what we at RGA call a lift chart. So lift charts for actuarial evaluations is our bread and butter. So what we look at with the lift chart is simply, can we see trends in segmentation of either, say, mortality or morbidity or longevity across the spectrum of a third-party data attribute. So as an example here on this slide, we're looking at that smoker propensity attribute, and it ranges from extremely low to extremely high on the x-axis. And then on the y-axis, what we have is your actual over expected ratio, your A over E's, and the red line shows that lift. And in particular, what is the lift? It is the mortality experience of each cohort. So extremely low comes in at 50% A over E, and then extremely high comes in at a 250% A over E, which we define as a 5 times lift. So the benefit of a lift curve is these can be directly used for building a cost-benefit analysis or just getting a preliminary understanding of if you were to incorporate the third-party data attribute smoker propensity into your pricing basis, you would have an expectation of how much that third-party data attribute would change your pricing. So as an example, if your pricing basis incorporated smoker propensity, you would expect that relative to your current basis, individuals who had a smoker propensity of extremely high would then have an increase in their mortality or premiums of 150%. So then the next question is how do you build a lift chart? So then how do we create these lift charts? Well, it's rather easy. You first start with your existing actuarial experience study using your typical fields, your expected benefits. So in this case, the number of deaths, since it's a mortality study. And then, of course, your actual deaths. And then you append the third-party data attribute into your experience study. So in this case, smoker propensity. And then within each smoker propensity level, you calculate your A over E's, which is the sum of your actual deaths over the sum of your expected deaths. And the outcome of that will create the chart here shown on this slide. So lift charts can also be used for models built on third-party data. So as an example, so instead of using a single variable, like we've been using smoker propensity, you can instead build a model using multiple third-party variables. So that could be smoker propensity and other socioeconomic and behavioral type of data. And that model will then be used to predict the actual number of deaths or morbidity outcomes like incidence rates, using all those different third-party data attributes as inputs. And then for each row in your experience study, append in that model prediction that was created from the model for each row in the experience study, append in the variables and predict the deaths based on the model from the previous step. And then after that, you want to order the rows in your experience study by that model prediction, allowing you to rank order the policyholders by their risk, so that then the next step is you can convert them into some type of quantile. So quantiles could mean maybe 10 equal groups of policyholders, which another phrase for that is deciles. But what that allows you to do is you can then say these policyholders are ranked from the best 10% of risk to the worst 10% of risk. And then the next step after that is within each of those equal sized groups, those quantiles, you calculate their A over E, which is, again, their sum of actuals over your sum of expecteds. And then last step is, like the previous slide, that chart, you create that line graph. Okay, so our last slide here on actuarial evaluations is a continuation of the previous slide, where it is third-party data being used to build a model, and that model can then be appended to our experience studies to determine how much segmentation of risk there is on our business. So as an example, the question that we want to assess is, relative to our existing actuarial assumptions, how much additional information does a model or variable provide? What we want to do is determine where in our data does this model work best, does it not work? So we can accomplish this by what we call slicing and dicing the lift curve across various different splits, age, gender, benefit amount, and then we can pull together a cost benefit of using, say, like a model or third-party data on our existing assumptions. So, as an example here with Truist Life, the chart here shows ranging from Truist Life scores from lowest to highest. What is the impact on mortality? And Truist Life has been a great success story in the U.S. and other markets that has, been very predictive of mortality, very consistently. And here on this chart, we're showing that mortality can go from less than 50% at the lowest scores to all the way up to approaching 250% at the highest scores. And in this case, Truist Life, as shown on the x-axis, actually represents equal percentiles of population within the U.S. So meaning that everybody in this chart on, like, say, the far left side of that 1 to 5 group is 5% of the U.S. population, and then on the far right of the chart represents the worst 5% of the population. So thank you, everyone, for your time today. I hope you enjoyed this session, and if you have any questions about anything you saw, please reach out to your RGA representative. Just in summary, I think one big takeaway we'd like you to have is when assessing third-party data, please consider this framework of both the analytical and actuarial evaluations, both in tandem. And that is all for today. Thank you.
This concludes our presentation on actuarial and analytical evaluations and third-party data. We hope that you found this enjoyable. Thank you.